So today is the last lesson in chapter 5 on savings accounts, and we're going to talk about annuities. So prior to today's lesson, you should have researched the different pros and cons to having annuities and how they are alike to savings accounts and how they are differ to savings accounts and what they are good to be used for. So today we're going to actually do the calculations of how to calculate the value that is in your annuity. Now remember that we use annuities typically for retirement purposes, that we put money into our accounts and they sit in there and they stay in there and they accrue interest as we continue to invest money into that annuity. A little different than a savings account where we can see the cash going in and cash going out. We typically leave annuities with money just going in until we're ready to use it at a retirement age. So today we're going to talk about two specific types of an annuity. One is considered an ordinary annuity, and an ordinary annuity is an account in which deposits are made at the end of each interest period. So after the interest is accrued, then we add more money or add our principals in there. An annuity due is an account in which the deposits are made at the beginning of the interest period. So you're able to accrue interest as soon as you start depositing that money in there. So you can see that an annuity due is going to have an extra period of interest attached to it. So it's going to have an extra calculation today. So let's look at our formulas that we're going to use. So I gave you a list of what all of these variables represent, but we're going to be looking for future values of an ordinary annuity first. Regardless of which type of annuity we're going to be calculating, we always find the ordinary annuity first. So we're going to calculate the future value by taking the amount deposited. Again, this is usually the principal, but a principal reflects that you make a one-time deposit. Amount deposited reflects that maybe you're putting away $200 every month or $1,000 every 6 months. So the amount deposited is usually a recurring payment. We're going to multiply that by 1 plus R. Now remember that R is the interest rate per period. So we're going to have to calculate our annual interest rate and divide it by how many times it's compounded. And then to the nth power would be the number of periods. Now, you're going to have to subtract 1 from that. So you want to make sure you use those double brackets and parentheses accordingly. And then when we're done with that, we're going to divide it by the interest rate per period one more time. Now, if this is an annuity due account, what we have to do is add an extra period of interest in. So we're going to take that future value and that we just calculated here, and then we're going to multiply it by another period of interest. So that gets multiplied by 1 plus R again. And R again is your annual interest rate divided by how many periods you're going to keep that money in. Okay, so let's look at how this works. So our first problem, we're going to be looking at an ordinary annuity. And then we're going to turn it into an annuity due in the next example. It says Amy deposits $1,000 in an ordinary annuity. So her amount deposited is going to be $1,000. I'm just listing all of my variables so I have them to plug into my formula. The account earns 6% compounded quarterly. So that's going to have to change to a decimal and divide that by 4. What is the future value of the account in 2 years? So we need to calculate N. So if we're compounding it quarterly, that's 4 times a year. For 2 years, our N is going to be 8. Now let's very carefully plug everything into our formula. So we're going to calculate that future value, and we're going to start with the amount deposited. And we're going to multiply that by 1 plus the interest rate per quarter to the 8th power minus 1. Notice the placement of the brackets. When you put this into your calculator, you want to use a double set of parentheses there. And we're going to divide that by 0.06 divided by 4. Now, if it's easier to calculate the top and then divide it by the bottom, you can do that. Or you can put everything into your calculator exactly as you see it. You might need an extra set of parentheses to separate the top. Now, this is probably the trickiest part, how to get this next number. So make sure you are clear on how to use that calculator. So when we calculate this out and I leave everything in my calculator, I find that the future value of the ordinary due account is $8,432.84. So that's the future value. Now, if I have to go from there and find the interest, it's calculated a little different because we just don't make one $1,000 deposit. That is a recurring $1,000. So what we have to do is figure out how much money we actually put in. So how I'm going to calculate this is we made 8 payments of $1,000. So I'm going to take 8 times 1,000. I got that 8 right from here. And mathematically, that's going to be 8,000. So that means that our interest that we earned in those 2 years was $432.84. So this is going to be the future value, and this is going to be the interest that we earned. Now, when I go to the next problem here, and I need to figure out if this was an annuity due problem, what I need to do is take my future value of the ordinary annuity, which I just did, and multiply it by one more interest rate. So we're going to take this same problem that we just calculated, and you'll remember here that our future value was $8,432.84. Now, since this is an annuity due, I want to add one more period of interest. So I'm going to take that $8,432.84 and I'm going to multiply that by 1 plus 0.06 divided by 4. And that's going to make my annuity due be $8,559.33. Again, I will calculate the interest the same way. I'll start with my final amount and I put 8 $1,000 payments in. Again, the math gives me $8,000. That means I earned $559.33 in interest. So those are two values. You can see that using the annuity due, I earned a little bit more interest, about $120 more interest than if it was just an ordinary annuity. So when you deposit that money, could increase your money by over $127, it looks like. All right, I'm going to give you a chance to try some problems. Again, list those variables and plug them into your calculators very carefully. Pause this video. When you're done, go ahead and play and check your work. So for the first concept checked, our amount deposited was $5,000. You had a 6% interest rate quarterly, and for 3 years that would take N to be 12 payments. So the future value of that ordinary annuity looks like this. You're going to plug this into your calculator. Now for this one, you can see that I calculated the top to be $978.09, and then I divided it by that interest rate, taking my future value to be $65,206.06. Then I went ahead and calculated my interest. So I started with my future value. I made 12. Again, I got that 12 from here. 12 $5,000 payments. So I made $60,000 in payments, giving me interest of $5,206.06. For the second concept check, we're going to turn this into an annuity due. So we're going to start with that future value right here, and we're going to multiply one more period of interest through. That's going to take our annuity due to be $66,184.15. When I take out my $60,000 worth of deposits, that makes my interest be $6,184.15. Look on Google Classroom for the rest of your practice for today.